Okay, so we're ready to learn about lesson 7.4. It's on special right triangles, one of my favorites. We're going to do a little bit of algebra review, radicals review, before we get into the geometry. So we'll review the algebra that we need for the geometry. So as you know, you can't have a radical in the denominator, and oftentimes that means you're going to do a whole bunch of things, which is what we're going to do down here. But this particular case, we happen to have radical 6 divided by radical 2. Since they're both under the radical sign, and since 2 is a factor of 6, you can just literally do radical 6 divided by radical 2 is radical 3. When I come down here, 5 is not in the radical sign, nor is 5 divisible by 3. So what we have to do is we have to multiply by radical 3 over radical 3, which is a form of 1, which is why we can do it. So I end up with 5 radical 3. Of course, radical 3 times radical 3 is 3. And it's a big, messy answer, but that's your answer. For this last one, this is going to be radical 2 times radical 2 is 2. So we have 3 times 2 is 6. So again, algebra review for what we need for geometry. So our first special right triangle is a 45, 45, 90. It's an isosceles right triangle, and it comes about because if you know that these two sides are congruent, then of course these two angles are congruent. And since we know that the sum of the interior angles of a triangle is 180, if this is 90 and this has to be the same but add up to 90, then this of course is 45 and 45. So there's our 45, 45, 90 triangle. Now, like triples, we can use these special triangles with patterns. So if I know that this leg is congruent to this leg, if I use x to represent one, I can certainly use x to represent the other one. But let's figure out what this would be then. So I'm going to label this triangle, triangle ABC, and I'm going to use the Pythagorean theorem. I know that x squared plus x squared is equal to my hypotenuse squared. Okay, and now 1x squared plus 1x squared is 2x squared. And if I take the square root of both sides, that will get me the length. Now I can simplify this. The square root of 2 is a big mess, big long messy decimal, but the square root of x squared is x. So I can pull out an x, and I end up with my hypotenuse being x radical 2. And this idea of a 45, 45, 90 being x radical 2 is what's really going to help you. It's going to work like Pythagorean triples. Very exciting. Now, the other special triangle is a 30, 60, 90. It's half of an equilateral triangle. So I'm just going to ask you to imagine an equilateral triangle that we know, if it's equilateral, that all the angles, it's also equiangular. So if that's 60, then this is 60, and this is 60. Well, since the altitude in an equilateral triangle is also a median and also an angle bisector, this is going to be 30 degrees and this is going to be 30 degrees. So what I started to say was an altitude is also a median. And so if I let this portion here be x, then this is x, which means one of the sides of the equilateral triangle is 2x, which means this side is 2x, and this side is 2x. So when I'm thinking about this black, now purple, triangle, this 30, 60, 90 triangle, here's the pattern that you're going to use. The side opposite the 30 is always x. The hypotenuse is always 2x. And let's figure out what the side opposite the 60 is. I'm going to go ahead and call this triangle DEF, just to make it easier for our Pythagorean theorem. So we know that the leg squared plus I don't know squared is equal to the hypotenuse squared. That parentheses are really important there. So if I go ahead and simplify the right side, 2 squared is 4, x squared is x squared. Now I want to get this by itself, so I'm going to subtract 1x squared from both sides. When I subtract 1x squared from both sides, I get 3x squared. Now I want to take the square root of both sides, and when I do that, of course, I get the length, the measure that we want of segment EF. Again, I can pull out an x. The square root of x squared is x. The square root of 3 is a big mess. And so what we have is that this side, the side opposite the 60, is always going to be x radical 3. So that's the pattern we're going to use for 30, 60, 90. The side opposite the 30 is x, the side opposite the 60 is x radical 3, and the hypotenuse is 2x. I'm sure this will make more sense when we get some examples in. So that was just leading into the note-taking guide. Let's fill this in. We already know that a 45, 45, 90 triangle, the hypotenuse is radical 2 times as long as each leg. And so that means that every hypotenuse, you take the leg and you multiply by radical 2. I will say, that's the way your book kind of presents it. I think that this is really, the visual is really the most important part. This is kind of a cool way to look at it, that the ratio is 1 to 1 to radical 2. We won't talk about that much, but I think that's kind of a cool way to think about it. So let's look at some examples. So example A, they tell you that this is 45 degrees and this is 90, which means that this is 45. So we have a 45, 45, 90 triangle. And if this side is 6, okay, because these two sides are congruent, then this side is 6. And we're trying to find the length of the hypotenuse. So what we know is that the legs are x, and the hypotenuse is x radical 2. So if I know that x is 6, my answer is 6 radical 2. In this case, we have 4 radical 2 is the x, okay? So if 4 radical 2 is the x, and I want to do x radical 2, I'm going to do 4 radical 2, that's the x, times radical 2. And radical 2 times radical 2 is 2, so this is going to be 4 times 2, or 8. Now, that's how I do it. That's how I show my work. I'm going to go ahead and fill this in just because I know it'll frustrate some of you if I don't. So we have the measure of the third angle must be 45 degrees to get a 45, 45, 90 triangle. The hypotenuse is radical 2 times as long as each leg. And so what they're saying in this first part is that if x is 6, then the hypotenuse is 6 radical 2. Even they don't have work to show here. For this one, we're going to do the leg times radical 2 again, still 45, 45, 90. And we know that x is 4 radical 2. We're going to multiply by radical 2. That's 4 times 2, or 8. Okay. Let's take a look at the next example. So in the next example, they want you to find the legs. In the last example, we found the hypotenuse. This time we want to find the legs. All right, so and I'm glad that they put that the legs are x. Sometimes they change the variables, but the legs are x, and we know always that in a 45, 45, 90, how do we know it's 45, 45? This is congruent to this, so this is 45 and this is 45. So x, x, x radical 2. So if 9 radical 2 is equal to x radical 2, it's kind of a no-brainer. That means that x is 9. You could, of course, divide both sides by radical 2 and get x equals 9, which is, of course, what they want us to do here. So we have 9 radical 2 equals x times radical 2. And so we're going to take the 9 radical 2 and divide by radical 2, and the x radical 2 and divide both sides by radical 2. And then this cancels and this cancels, we get x equals 9. But really, this is all I would show. Obviously, I would write my answer. So this makes it look like there's a lot of work to show. There really isn't a lot of work to show for these. And I know that will make most of you very happy. All right, go ahead and pause the video and do your 2 checkpoint problems. Okay. Hopefully you've finished, and here I have 2 radical 2 is x. Here's an example of them putting in an x there, even though it's the hypotenuse. So we know that x is 2 radical 2. I want the hypotenuse, which is x times radical 2. So I'm going to take 2 radical 2 times radical 2. Radical 2 times radical 2 is 2, and my answer is 4. In this case, x is a leg, the hypotenuse is x radical 2, and literally, 12 radical 2 equals x radical 2. So x is 12. Literally, that's all there is to it. Moving on to the 30, 60, 90, we know that the hypotenuse is twice as big because we have x and 2x as the shorter leg, and the longer leg is radical 3 times as big. Be careful with that. I know students get the radical 2 and the radical 3 mixed up, so you're going to have to make sure you do some studying or make some flashcards or something. So the hypotenuse is twice as long as the shorter leg. The longer leg is radical 3 times as long as the shorter leg. Their ratios here are 1, radical 3, 2 for the 30, 60, 90, in that order, respectively. Again, this is the most important part for me. This is how I remember it. The side opposite the 30 is x, the side opposite the 60 is x radical 3, and the hypotenuse is 2x. And that's the pattern we're going to use in our next examples. So here they're talking about a guitar pick, but we're basically just looking for the height here. We have an equilateral triangle. They say remember that in an equilateral triangle the altitude is also the median, so altitude BD bisects segment AC, which we can see because if you have 16 here and 32 here, 16, 16, it works out. So we have a 30, 60, 90 right triangle. How do I know that? Because this is 90, this is 60, that has to be 30. The side opposite the 30 is x. You can check that 2x equals 32, of course, so that still works. The side opposite the 60 is x radical 3, so I know that my answer is 16 radical 3, and normally you would just stop there, but because it's a word problem and they're asking for a length in millimeters, of course you would get a decimal approximation. Most of the time, though, your answers are going to be in simplified radical form. So unless it says, you know, approximate height. So the height here is going to be take the 16 times the radical 3, put it in your calculator, round, let's round to tenths, and we get 27 7/10 millimeters. Okay, so this example, again, we have a 30, 60, 90. Now they want you to find both variables. Don't be thrown by the fact that they're using a y. At least they have x is the side opposite the 30, so that's nice. The side opposite the 30 is x, the side opposite the 60 is x radical 3, and then this side is always 2x. So to figure this one out, we haven't done this yet, I know that x radical 3 is equal to 8. That's the only piece of information that I know. So let's solve this. If I divide by radical 3, I have to divide by radical 3, and I end up with x equals 8 over radical 3. Well, we know we can't leave that radical in the denominator, so we're going to multiply by radical 3 over radical 3. We get 8 radical 3 over 3. So my x is 8 radical 3 over 3. This is 8 radical 3 over 3. Now they also want the hypotenuse. The hypotenuse is double that. So that's going to be 8 times 2 is 16 radical 3 over 3. Okay, 16 radical 3 over 3. That's how I would show my work. Okay, that's how I would show my work. I'm going to go ahead and fill this in. It's the short leg times radical 3. We already know that 8 is equal to x radical 3. And to get x by itself, we have to divide by radical 3. And then, of course, we don't like leaving that radical 3 in there. So we're going to multiply by radical 3 over radical 3 so that we end up with 8 radical 3 over 3. Here we divided by radical 3. We multiplied by radical 3. And so the hypotenuse is always 2 times that. So it's 2 times whatever x is. So we're going to do 2 times 8 radical 3 over 3 is 16 radical 3 over 3. Okay? All right. One more word problem, 2 more checkpoints, and we're done. So in this case, they want to find out this distance here, this height. This, I can't barely read it, but that's supposed to be 60. So we have a 30, 60, 90. In fact, I'm just going to come over here and redraw that. All right, they give me that the hypotenuse is 24 inches. The side opposite the 30 is always x. The hypotenuse is always 2x. The side opposite the 60 is always x radical 3. So here's the equation that I'm starting with. I know that 2x equals 24, x equals 12. So I know that this is 12 and this is 12 radical 3. Basically, I'm done, except for the fact that it's a word problem and they want it in inches. And they want how far, I'm assuming they want it rounded. So we would put that in a calculator. 12 radical 3, 12 times radical 3 is going to get you approximately 20.8 inches. Let's go ahead and fill this in. The length of the hypotenuse is 24 inches. You know the hypotenuse is always twice as long as the shorter leg in a 30, 60, 90. And so you get 24 is equal to 2, I don't know why they're using s, but 2 times s. And then so 12 is this part here. Okay, 12 is that part here, by dividing each side by 2. Now, to find the longer leg, which is what we're looking for, that's what they were asking for, you know that the longer leg is the shorter leg times radical 3 in a 30, 60, 90. So, if you know that x is 12, then the side opposite the 60 is 12 radical 3. That would be fine, except it's a word problem, so you put it in your calculator, big mess times 12, round 20 and 8/10 inches. You'll notice I've crossed off the 5th checkpoint, but go ahead and pause your video and do 3 and 4. Okay, so for problem 3, the side, now this is tricky. The side opposite the 30 is x, okay? And they are asking to find this length, but don't get confused by the x in our pattern to the fact that they just called this side x. So I know that x equals 2 radical 3, and the side opposite the 60 is x radical 3. So I want to take the 2 radical 3, that is x, times the radical 3. 2 times 3 is 6. My answer is 6 here. If I wanted to find this one, this would be x radical 3 times 2, so 4 radical 3. All right, over here we have a 30, 60, 90. How do you know? Because I can see that this big triangle is an equilateral triangle, because 12, 12, and 12, which means 60, 60, 60, which means that's 30. Well, as soon as you get this is 60, that has to be 30. So the side opposite the 30 is x. The hypotenuse is 2x. The side opposite the 60 is x radical 3. And that's what we're looking for. So if you know that x is 6, it's literally just that simple. 6 radical 3.